Hiya. This is objective 4, which means it's beginning of 8B, staffing analysis. And the file that we have to have open is something called staffing analysis. I think I put it into the chat. Can't remember. I'm going to have to make sure I do that anyways. Staffing analysis, and you have it open, and we're going to begin on page 2. Or step number 2. Next. I'm going to have to go up here and close this guy off. Is what we need here, staffing analysis. Yes, it is. And file you, of course, because I've done this like 100 times today. You, of course, we're going to have to click on your yellow band and enable editing, file, save as, PC, browse, and of course, desktop. I'm just going to call it my initials. Overwriting that. Yes, I'm okay with that. Okay. And when we get to do it in class, you'll see that I'll be doing a lot more hand waving than you'll see in the video, obviously. Excuse me. Solver is a what-if analysis tool, which you can find an optimal, maximum, or minimum value for a formula. One cell subject to something, and I'm using air quotes here, constraints or limits on the values of the other formula cells in a worksheet. Very, very cool. For many years, I used to teach Solver as my day-to-day, one of my day-to-day techniques, but recently I've seen it not become as popular as in the past, but that doesn't surprise me. So you could do the reading about the paragraph here and the paragraph here, about the objective cell, the decision variables, or as I call them, variable cells, as well as something called constraint cells, or the limitations. All right, so now, if you do not have data tab, analysis, and solver, if you don't have that, what you're going to do is going to go to file. Well, you will because you'll be doing it in class. Then you're going to go down to, and I'm doing this from my memory, more, options, then it is add-ins, and then you want to make sure your analysis tool pack is active. So you click on that, and then you're going to go down to go, and that's going to install it onto your Excel. Obviously, I can't do it twice. Once it's in, it's in. All right. No further ado, let's have a go and see where it takes us. So this takes time, and it's not the clearest of exercises. In fact, it's as clear as mud. And I've got 45 minutes. I'm not even going to get it done, but I'll do as best as I can. So we're going to go to the Data tab and Data tab Analysis, and we're going to see if the solver displays. It should do. It's going to be there. If solver displays, it's been installed. If it doesn't display, it's not been installed. No kidding. So steps below are how to install it. I've just shown you, and that's what it looks like. And go. So then we're going to fast forward down to activity 8.08, understanding a solver worksheet. Okay. So we're going to be in the evening shift tab. Okay. You've got evening shift, weekly sales, and weekly awards. Okay. And in E4, we're going to type in 1 and press enter because we want to complete the information for schedule or schedule B. So right now, we need to insert E1 in this cell so everything is filled out. I'm not sure why, and I think we're going to find out very soon. So E1, sorry, E4, and I'm going to type in the value 1. E4, I'm going to type in the value 1. And I'm going to learn how to count. So E4, type in 1. And enter. Well, the internet has not blown up on me yet. So then what we're going to do, we're going to examine the range A2 to K8 and compare it with my screen. Because you'll be practicing this again, I'm not going to bother with it. So you've got 6 possible schedules are labeled A through F. B lists the consecutive days off for each schedule. For example, anyways, you guys can read it. Blah, blah, gender. So what we're going to do, we're going to go down to C10. You're going to look at the formula bar, and basically you're going to see where all the pieces kind of come together. It would have been a like all the formulas are here, so you can see how they all kind of tie together. Okay, so C3 to C8, it represents the number of servers. Schedule A, currently 0 because no servers have been assigned to any schedule. C3 to C8 is shaded. These are decision variables. Mark that one. The values will change to achieve the desired result. So like the goal seek, kind of like the data table. These are the cells I'm going to allow you to change and try and find the thing that you want to change. Right. So, okay. Again, C14, you're going to examine the formula. And C15, formatted using calculation cell. So finally, we've looked at all those, and we're going to select the range E12 to K12. These cells represent the minimum number of servers required to serve the number of customers expected each day of the week. So let's go to E. E12 to K12. There it is. D, E, F, G, H, I, K12. And these are here. And if you notice, each one of these are integers or numbers. There's no formulas involved in these guys at all. And so right now we've got schedule 0, and we need 22, 17, 14, 15, and so on. Okay. Recall the constraints are conditions or restrictions that must be met. So you just can't willy-nilly put numbers in and hope it works, because quite often there are things that we don't take into consideration, or there are formulas or functions, I would call it downstream. Okay, so they say the number of servers scheduled must be greater than or equal to 0. Yepper. So that would be constraint. So we're going to go to E10, and the formula in this row multiplies the number of servers assigned. So D, E, F, G, H, I. So, wow. E3 multiplied by C3 multiplied by E3. C4 multiplied by, you get the idea. And so on, and so on, and so on, and so on. But these relate to these cells. It's almost like a great big spider web, or house of cards, if you will. So in C3, and in the name box arrow, making sure I've not done anything wrong. Yep. Notice that C3 has been named Sunday, Monday. C3, Sunday, Monday. C4, Monday, Tuesday. So on, and so on, and so on, and so on. Okay. Yeah, we've looked at it. Now we're aware of all of this stuff, we're going to start using the solver. In this activity, you're going to use the solver to determine the minimum payroll expense. That is to say, the minimum number of servers who can be on duty and still meet expected customer demands. All right, finally, halfway down the page, click on cell C15, the objective cell. Okay, so data tab, analysis group, solver. Okay. C15. I am in C15. Data tab. Analysis group solver. Data tab. Okay. So right now it says set objective. Whatever that cell is, What do you want to happen to it? Or do we want something to happen to it? Let's go figure this part out. There's going to be a lot of discovery, guys. Okay, so we've got that done. And the set objective box C15, and it must be absoluted. Mine looks like yours, yours looks like mine, and ours looks like the book. So in the solver parameters, under set objective if necessary, click on the minimum option button. So what is it? Do we want this value to be highest, lowest, or equal? So they want it to be the lowest possible variable. And that's why we're grabbing the minimum. Alrighty. Lucky for us, min is there. Normally our default is max, but today, for this purpose, it's min. Okay. So you already know the options. And by changing which variable cells. Okay. This is what I want to do. But I'm going to allow you to change more than one cell. Which ones are they going to be? C3 to C8. When we highlight it, by changing C3 to C8, and it's already selected this range of cells here, C3 to C8. Yes, it's absoluted. Okay, you want me to select the C3 to C8? And yes, I shall. Exactly the same. Quite often you'll find that these tools are quite intuitive. Oopsie. And subject to the constraints. So these cells, subject to constraint. What constraint? The first constraint is what? So we're going to say subject to constraints. Let's add a constraint. Some of these are really, really, really weird. Trust me. So with the insertion point linking in the cell reference, we've done that. Okay. Now the one thing I found with this exercise, I quite often lost track of where I was. So cell reference. Okay. C3 to C8. Integer. And that's it. So the rule, if you want to call it that, is C3 to C8 equals or is an int. So every cell in this range I've selected, one of the rules, it must be an integer or a whole number. 1, 2, 3. You can't have 1.5 employees, yeah? Kind of makes sense to me. Okay. There's a rule. There's a constraint. Look at us go. Okay. And compare, and looks like that. Only an integer. And if you like it, what we do, click on, oh, so we did a click on OK. Sorry about that. I got ahead of myself here. The add constraint dialog box closes, and we've seen it. Now we're going to add a second constraint, or a second rule, if you will. Okay. So let's add again. Okay. Cell reference, doing what and why, or how. Okay. So again, C3 to C8. Greater than or equal to 0. Okay. No value could be negative a person, right? So C3 to C8 greater than or equal to 0. When you break it down, some of these things are so logical, but if you try and smush it together in one go, it's pretty intimidating. Okay. And what's next? I'm going to add a third one. Your friends and mine, C3 to C8. Once we did that, looks good, looks good. And constraint limitation requires that the number of servers assigned to each schedule be a positive number. A negative number of servers cannot be assigned. No kidding. It's got to be greater than or equal to 0. So now we've got our second. Let's go and add a third one. This one's slightly different. Let's see where this one wants us to go. So, add a third one. What are we going to do? Where are we going to go? Or why are we going to go there? So we're going to select the range E10 to K10. Oh, greater than or equal to E12 to K12. All right, that will make sense to me. My cell reference is E10 to K10, which presently is 0. We want E10 to equals greater than or equal to, better make sure that's correct, K10. F10, sorry, to K12. F10 must be greater than or equal to F12. G10 must be greater than or equal to G12. So my constraint is going to be E12 all the way across to K12. Let's make sure it's good. It should be, but you never know. Does it look like this? Yes, it does. Boy, we're doing good today. So, constraint requires the number of servers assigned to each shift be greater than or equal to the number of servers required each day to meet the projected demand. Again, you look at it this way, it makes sense. Mind you, you got to know this stuff to begin with. I've never worked in a restaurant. I don't know that. So I'm going to take it. So on Saturday, the number of servers must be at least 24. Okay? And then we're going to compare. Okay? Yep. Yep. And yep. Okay. At the bottom of the solver parameters, we're going to click on solver. Then in the solver results dialog box, we're going to say keep solver solution and OK. Okay, so we like this. It's a keeper. Okay. Solve. Like it, keep it. Is there anything else? Do we want to return? Do we want to restore? Do we want to outline? Is there anything else before we click on OK? Okay. Keep solver and OK. That's it. Keep solver. So we like that. That's a good thing. Okay. Why? We will find out in a second. So the decisions variable, shaded area, displays the number of servers that should be assigned. Okay, never mind. Now, we're going to make a note. This is one possible solution, because later you're going to consider alternatives with a different distribution of staff over the week. So this is what we got. Is it better? Is it worse? I don't know. Alrighty. And that brings us to the end of that page.